From the beautiful South Studios of Way Happy, this is Mr. Meyer, and we were continuing down that road of vocab for no other reason than we just want to be smarter, more educated people. All right, and we want to be able to communicate with those smart and educated people, and so we will use their kind of logic. And what are we talking about? We are talking about inductive reasoning. What is inductive reasoning? Inductive reasoning is when you can make a conjecture, when you can make up a rule that you think may or may not be true based on things that have happened over and over and over again. Like, I keep making 10-minute videos. So you could probably make a rule that every video has to be 10 minutes. That may or may not be true, but you could make that conjecture because I keep making 10-minute videos. A counterexample is when you show my conjecture is not true, when you go, hey, that last video was 10 minutes and 40 seconds. Therefore, they're not all. And that's a counterexample. That is disproving my conjecture that I tried to make. And then deductive reasoning. So inductive reasoning, you make your guess or your conjecture or your theory or whatever you want to call it, your conjecture. Let's call it conjecture because then that's what everyone will like. If you use inductive reasoning, you're doing it off of past examples. And deductive reasoning, that means you're using laws and definitions and stuff. So again, a conjecture is an unproven statement, right? And it's based off of your observations. So if you used your observation skills, you would be using inductive reasoning. Right? A deductive reasoning is when you use laws of logic, right? You're using law. You are using definitions. You are using facts, right? And that's what we like. We like deductive reasoning. There's also this thing called the law of detachment that says, and you should always read this stuff and go over it and then ask me in class, but the laws of detachment are, if the hypothesis is true and a conditional statement is true, then the conclusion is also true. In other words, it's all true, right? Remember this P implies Q thing? Laws of detachment say, if this is true, right, then this is true and this is true, right? That's what it says. And so, and then there's the syllogism that is a little more confusing. It says if hypothesis P, so, if something happens, then this happens. And then it says if this exact same thing happens, then something else will happen. So then you can jump straight from P to R. Okay? So if they are true, then P to R is true. So if this happens, then this happens. It's kind of like a series, right? And then this happens, and this happens. Then I can jump from P to Q. So P then Q, Q then R. Well, if that's all true, then you could just go P to R. And that is the law of syllogisms. The law of detachment says these two things are true. The whole thing is true. And then the law of syllogism says, hey, look, I can go down a nice path of shortening. All right, let's see what we got. First thing I'm going to do is some deductive reasoning here. I see a square in figure 1, then 3 squares in figure 2. It's 2 tall and 2 to the left, I'm going to say. I'm starting at that midpoint right there, right? That's my origin in my mind. So here it is. Now figure 3 is 3 up and 3 left, and figure 4 is 4 up and 4 left. So if I had to draw figure 5, I would go 5 tall, 1, 2, 3, 1, 2, 3, 4, 5. It's really good drawing. And 1, 2, 3, 4. I need one. That's good right there, right? And there it is, my beautiful drawing for Fig 5. And that is me going based off observation. That's my conjecture, right? I'm thinking that's what's going to happen because I looked at what was happening and that's what I think. So there you go. How about this? Make and test a conjecture. Example 2. Make and test a conjecture about the product of a negative and a positive integer. Integer is like a nice, pretty number. One's positive, one's negative. So I'm going to make a conjecture. If you take a positive number and a negative number, and you multiply them together, that's what product means. Product means multiply. What would you say? I would say it's always negative, right? I would say it's always negative. And that is my conjecture that you could now try to prove or disprove by coming up with one counterexample. Remember, a counterexample can disprove my whole thing, right? If you can show me one time that that's not good, then you found a counterexample and I have to go back to the drawing board and make a new conjecture that I think is true. How about example 3? A student makes a conjecture about absolute values. All right, what's their conjecture? The absolute value of the sum of two numbers is equal to the sum of the two numbers. So they're saying the absolute value of 5 plus 3 is equal to 5 plus 3. That 8 is equal to 8. Hey, they are right. Find a counterexample. Well, let me try another one. 2 and 6, right? Is that equal to 2 and 6? Let's see. Absolute value of 8, is that equal to 8? Is 8 equal to 8? Oh my goodness, this is starting to look true. How am I ever going to find a counterexample? And hopefully you're screaming and saying, hey, why not pick a negative number, right? Like 5 and negative 3, absolute value is equal to 5 plus a negative 3. No way is that going to work, right? 5 plus a negative 3 is 2. Absolute value is equal to 2. Wait, that works too? What about the other way? Negative 5. I just got to find one time it doesn't work, and we would be so happy, right? Or what I like to say, we would be way happy. And let's see, that would be negative 2 absolute value is equal to negative 2. Is that true? 2 does not equal negative 2. There is my counterexample. Negative 5 and positive 3. I'm sorry, students. You have to go back and find a new conjecture that you think is true. All right, what about this? Example 4. They want us to use the law of detachments. What statement can we make? If a figure is a square, then, here's a nice condition, then it's a rectangle, right? So nice conditional statement. If it's a square, then it's a rectangle. Now, if you know quadrilateral ABCD is a square, then what do you know? Well, through the laws of detachment, we know that that first statement is true. If you are a square, then you are a rectangle. That is true. So, because the definition of rectangle is 4 sides and 4 90-degree angles, and that's what a square has. So that is true. Then I know quadrilateral is a square. Through the law of detachment, I can say that quadrilateral A, B, C, D, since it is a square, then I know it's a rectangle. Is a rectangle. There you go. I can make that statement, and I can make that statement true because I know that it's a square, and through the laws of detachment, all squares are rectangles. All right, what about the last one? Using the law of syllogism, you need to come up with something that's all right. So if soccer practice is canceled today, then you can go to the mall after school. If it's raining today, then soccer practice is canceled. Ooh, I might see it there, right? I might see this. If it's raining today, then soccer practice is canceled. If soccer practice is canceled, then you can go to the mall after school. So there's a nice logical step there, right? I can go from yellow to blue to green, right? If it's raining, soccer practice is canceled. If practice is canceled, you can go to the mall. So I can now make this a little more simplified to say, if it is raining, then you can go to the mall. Right? Why can I say that? You can go to the mall because I know soccer practice would be canceled. Right? That's what the rules say. It says soccer practice is canceled if it's raining, right? And if it's canceled, you can go to the mall. And so that's why it's true. What about this one? If a figure is a rectangle, then all the interior angles are right angles. Okay. If the figure is a square, there's a new statement. Then the interior angles are right angles. So I need an if to a then, and then I got to take that then becoming an if. But the bad news is I have if, the highlighted yellow, the sames. Did I use the wrong color? I did. The interiors are supposed to be blue. I don't. Sorry. Color coding, not my cup of tea. If a figure is a rectangle, then the interior angles are right angles. If it's a square, then the interior angles are right angles. So notice both times the then part is the same. And that's not an if then and then an if then where that middle pieces are the same. So unfortunately, I can't really say anything. I can't say if a figure is a rectangle, then it's a square. I can't say that. That's not true. Because it's not always true. Sometimes true, but not always true. So therefore, I have no chance. And that's it. I can't do it, right? All right, that's it. Stay happy, and we'll see you next time.